In this new e-learning, we want to show you how to create analog inputs for instruments and PID controllers. So I still have my ACM database previously created for my didactic process with all my PUs and PSUs, as well as my instrument list. So from my instrument list, I will populate this instrument and this controller. So let's create the analog input for the TIT 2202. So first, I need to go to my ACM database, right-click on my controller, select Add New, go to I/O processing, type, then select analog input. So in brackets, it is the versions number. So let's take the highest one. Here the name will be automatically completed. The descriptions will be my product temperature. My process unit and subunit is a 22. So let's select batch mixer 2 tempering 2. Finish. The ISA code will be T for temperature. The item number will be 02. And then we get to the specific attributes that are options. So if you have analog input cards that can detect out of range, you can set this attribute to true. If you have some wire broken detections, you can set this parameter to true. You can as well preset all the timers for the alarm detections low, 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 high, and high, high. You can set the different alarm limits. You can as well define your engineering unit minimum. So let's start from minus 50 degrees C to 150 degrees C and set some alarms, for example, for the high at 125, for the high to 115, for the low, let's say something like minus 20. Oops, sorry, minus 20. And for the low, minus 30. Then you have the min row value and the max row value. So that's the value read from the analog input channel. So let's say we are using kind of flex IOs. And if I remember well, for 420 milliamps, the value will be 30,840. And the unit, you can determine degree C, for example. For the IO list mapping, I will show you that in a later video. And I click Finish. So now you can see in the class view that I have created one analog input with the name DI1 underscore MI1 underscore T2202. Now let's create the controller. So once again, I will go to my didactic platform, right click, add new. Here I have regulatory control for my PID e-block. I will select once again the highest version. click next. The name will be automatically filled. This is description filling flow, here. Filling flow. It is in my PU2 and PSU1. So let's select the batch mixer 2 inlet 1, finish. It is a flow controller. So I select FIC and my item number will be 05. The controller will create as well one analog input. So I need to select once again all the different options for this flow. So min EU, I would say 0. I would put 300 as max EU. Here I will use as unit liter per hour. And as raw value, I will use 35,840. That's the value from my Ethernet cards or Flex IO cards. Then I have my attributes for my PID controller. So you can set some set point ramping or not. You can specify the ramping value as unit per minute. You can select if it is a cascade loop or not. You can select the set point timer informations. You can select the deviation alarm. You can select force automatic mode at run transitions. You can select the deviations if the deviations are in engineering units or percentages. And if you have a CV ramping or a split range. So in this particular case, I will not set any ramping value. I do not have any cascade. I will put a 2 seconds timer to detect my at set point informations. My deviation alarm will be between 5 to 10. Oh, that's the opposite. So 10 and here 5 for the minor. And here deviation limits, I will set to true for the percentage. And then that's the IO mapping. You can as well specify if you are controlling a control valve or a VFD. And in the case you have already specified VFDs, here you will have the list of the different VFDs. In this case, I don't have it yet, so I click Finish. That's it, how to create PID controllers. Now that we have created our analog instruments and controller, we can create as well some digital input device. So if I look to my element list, I will choose to create one LSL level, like this one, and one LSH level, the second one. Okay, so in my ACM database, go to controller, add new, EO processing. We have switch high and switch low. So in the case of the LSL 1105, I will select my switch low. So the name will be automatically built. As descriptions, we have empty level. It belongs to the plant unit 1 and subunit 1. Here, finish. It is a level switch low. The item number is 05. The fault timer preset and inbound timer preset, let's keep as default. And the input, we will map that later on. Click finish. Let's repeat for the level switch I. So right click and new. And I select EO devices, switch I. Next. Description will be overflow level. It belongs to the plant unit 1 and subunit 2. So this one, finish. It is a level switch I. The item number is 03. And then I can specify my fault timer preset and inbound timer preset. Then I click finish. And it's done. So now, with this video, you are able to create analog inputs. You are able to create PID controllers, as well as switch high and switch low informations.